Hello, welcome to Pre-Cal Lecture 4.6b. This is the last new material that will be covered on the fall final exam. And we're going to talk about combining logarithmic expressions. So if we have more than one log expression, we're going to combine them into one. So really we're going backwards from what we did in the last lecture. So we're on page 9 of your note packet for 4.4 to 4.6, and we're going to finish this note packet up. So our first example, and I went ahead and put the three formulas for combining logs, or our properties of logs. So we want to convert into one log expression, log base 10, all right, of x plus 5 plus 2 times log base 10 of x. Okay, so we really can't do anything with this one. That 2, though, we can rewrite this as log base 10 of x plus 5 plus log of x squared. So I'm going to take that coefficient and make it into a exponent. And this is plus, so we have a sum, so that's the same as a product. So we're going to take from here and go back to a product. So we would have log of x plus 5 times x squared. All right, and if you want to, we can put a bracket around all that so that we know that you are taking the log of all that. Now, we don't need to distribute the x squared. Okay, we can just leave it like that. You don't need to make that into x cubed plus 5x squared. You can just leave it as a product like that. Okay, on your notes, just want to make sure we highlight this, that bases must match in order to combine logs. If you're not at the same base, then none of this combining or expanding, none of that works. All right, our next example, the second one on page 8. All right, and I said at the beginning we're starting on page 9. I apologize for that. We're actually starting on page 8. Okay, so apologize if that was confusing. We want to convert into one expression. We've got 3 log base 4 of x minus 2 log base 4 of z plus 2 log base 4 of w. So first of all, what we want to do is take care of these coefficients, make them into exponents. So we've got log base 4 of x cubed, so bring that 3, make it into an exponent, minus log base 4 of z squared plus log base 4 of w squared. Okay, now we're going to, let's see, we always combine left to right. So let's combine these two, the first one and the second one. So we're going left to right, and that's a minus sign, right? A minus sign. So we've got a quotient going on here. We've got log base 4 of x cubed over z squared. So I've combined these first two, and then plus log base 4 of w squared. Now we have a plus sign, so that's a product. So I'm going to multiply the w squared So we've got log base 4 multiply w squared by x cubed over z squared. So we would have x cubed times w squared over z squared. Make sure you go left to right or you'll end up with the wrong thing potentially in the denominator. All right, so that's combining them into one log. Okay, now flip over to page 9, which you were probably already there for a little bit and confused as I worked these problems. So sorry about that. But luckily this is a short lecture. So what we're going to talk about is a special log called log base e. So log base e is the natural log of x, whereas log base 10 we just call log. Log base e is the natural log. All right, natural log. We symbolize the natural log with just an ln, non-capital letters, ln, and that is equal to log with a base of e. So that's the natural log because you see it in so many natural processes, just like when we talked about the number e. Okay, and your calculator has, I'm sure you've seen this, has a natural log key on it. Okay, so got a couple examples using natural logs. We want to convert into one expression. And that's going to be the natural log of x minus the natural log of y plus the natural log of z. Okay, work left to right. Otherwise, you're gonna make a mistake on the denominator. So this is a minus sign between the first two, so this is a quotient. Our first two is a quotient. So this is going to be the natural log of x over y, combine those two, plus I'm going to write natural log of z separately. Now that's a plus, okay? So now we have a product. So I multiply the z times the x over y. So this would be the natural log of x z over y. Okay, so that's why you work left to right. Otherwise, you could end up, if you did these first, you'd end up with a z on the bottom. Okay, our last problem from this packet, I think I can get this in here. We want to simplify. So this would be combined into one log, if you can. The natural log of y to the 7th over z squared minus the natural log of y cubed over z minus the natural log of y to the 4th over z. Okay, we're just going to go left to right. So first, let's combine the first and second term. So that's going to be the natural log. I'm going to do a big bracket here. It's y to the 7th over z squared divided by y cubed over z. And then minus this last term, I haven't done anything with that yet, the natural log of y to the 4th over z. So this is going to be the natural log. So this bottom fraction we're going to flip and multiply. So we have y to the 7th over z squared times z, I'm flipping the bottom, over y cubed minus the natural log of y to the fourth over z. Okay, so y to the seventh over y cubed would leave, so what that leaves is y to the fourth on top so y to the seventh over y cubed leaves y to the fourth on top, and then z over z squared leaves a single z on bottom, minus the natural log of y to the fourth over z. Now we're going to combine these two. That's going to be the natural log of y to the fourth over z divided by y to the fourth over z. Well, y to the fourth over z divided by y to the fourth over z. That's just going to be the natural log of 1. Okay, so that's like saying, so if we set that equal to x, that's like saying natural log is base e to the x is equal to 1. Well, what power is x in order to equal 1? Well, it has to be 0. X equals 0. So combining this all into one expression would be, you'd have the natural log of 1, and then I went ahead and told you what the natural log of 1 is, and it is 0. We changed it to an exponential because natural log is log base b. E to the x is equal to 1. Okay, so your homework is worksheet 4.6b, and there's six problems on that where you're combining more than one log expression into one, if possible. All right. Talk to you on the next one.